In today's topic, we're going to discuss about introduction to angles. But first, let us define angle. Now, an angle is the union of two rays that share a common endpoint. And in figure 111, ray BA and ray BC share a common endpoint, B, and this forms an angle. There are four common ways to name an angle. Number 1, using the 3 points. When naming an angle using 3 points, the common endpoint is always named in the middle. So in figure 111, the angle can be named as angle ABC or angle CBA, since B is the common endpoint. Number 2, using the common endpoints. When naming an angle using the common endpoints, simply use the point. In figure 111, the angle can be named as angle B. Number 3, using Greek letters. When naming an angle using Greek letters, you can identify angles by symbols from the Greek alphabet, such as alpha, beta, gamma, theta, and others. So in figure 111, the angle can be named as angle theta. Number 4, using numbers. When naming an angle using numbers, you can identify angles by numerical labels. So in figure 112, the angle can be named as angle 1. An angle is in standard position if its vertex is located at the origin and one ray is on the positive x-axis. The ray on the x-axis is called the initial side and the other ray is called the terminal side, as shown in figure 113. An angle is measured by the amount of rotation from the initial side to the terminal side. If measured in counterclockwise direction, the measurement is positive. But if measured in a clockwise direction, the measurement is negative, as shown in figure 121. If two angles in standard position have the same terminal side, they are called coterminal angles. To find coterminal angles, simply add or subtract multiples of 360 degrees or 2 pi radians from a given angle. In figure 121, 120 degrees and negative 240 degrees are coterminal angles because adding 360 degrees to negative 240 degrees will result to 120 degrees, and subtracting 360 degrees and 120 degrees will result to negative 240 degrees. But how about in radians? Let's try this. Identify the positive and negative coterminal angles of 5 pi over 4. To get the positive coterminal angle, simply add 2 pi to 5 pi over 4.
To add fractions, they must have the same denominator. Since the denominator in 5 pi over 4 is 4, express 2 pi as 8 pi over 4. Since the denominators are the same, add the numerators.
And to find the negative coterminal angle, simply subtract 2 pi to 5 pi over 4.
Following the same process, and instead of adding, we simply subtract negative 2 pi to 5 pi over 8. With that, the positive and negative coterminal angles of 5 pi over 4 is 13 pi over 4 and negative 3 pi over 4.
Complementary angles. Two angles are complementary if the sum of their measure is 90 degrees. Each angle in the pair is known as the complement of the other angle. As shown in figure 124, 30 degrees and 60 degrees are complementary angles because their sum results to 90 degrees. Supplementary angles. Two angles are supplementary if the sum of their measure is 180 degrees. Each angle in the pair is known as the supplement of the other angle. As shown in figure 125, 120 degrees and 60 degrees are supplementary angles because their sum results to 180 degrees. Quadrant angles. Quadrant angles are angles that lie in the four quadrants of the coordinate plane.
Examples in degree and radian. In degrees, in quadrant 1, we have 0 degree to 90 degree. Example of this is 30 degrees, 45 degrees, and 60 degrees. In quadrant 2, we have 90 degrees to 180 degrees. Example of this is 120 degrees, 135 degrees, and 150 degrees. In quadrant 3, we have 180 degrees to 270 degrees. Example of this is 210 degrees, 225 degrees, and 240 degrees. In quadrant 4, we have 270 degrees to 360 degrees. Example of this is 300 degrees, 315 degrees, and 330 degrees. In figure 1 to 7, this is in radian.
Quadrantal angles are angles in standard position whose terminal side lies on an axis. Examples of quadrantal angles include 0 degrees, 90 degrees, 180 degrees, 270 degrees, or 360 degrees. But in radian, we have 0, pi over 2, pi, 3 pi, and 2 pi. Converting between degrees and radians. It involves the process of changing an angle from one unit of measurement to another. Angles can be measured in degrees and radians. Conversion between degrees and radians. To convert degrees to radians, multiply degrees by pi radians over 180 degrees. To convert radians to degrees, multiply radians by 180 degrees over pi radians. Now always remember to apply these two conversion rules. Use the basic relationship between pi radians is equal to 180 degrees.
Let's try this. Convert 135 degrees to radians. Step 1. Use the conversion formula. Step 2. Substitute 135 degree. Step 3. Multiply the numbers. Step 4. Simplify the fraction. Find the greatest common divisor or GCD of 135 and 180, which is 45. So 135 degrees in radians is 3 pi over 4. How about converting radians to degrees? Convert 9 pi over 2 radians to degrees. Step 1. Use the formula and substitute 9 pi over 2. Step 2. Cancel out pi and radian. Since pi and radian appears in both the numerator and denominator. Step 3 is to multiply and divide. Multiply 9 times 180, it is equal to 1620 degrees. Divide 1620 to number 2. And we should have 810 degrees. So 9 pi over 2 radians is 810 degrees.